Hey guys, Mr. Kruger here working on the Unit 4 review, which is exponents and radicals. The first section talks about classifying each number as an integer, rational, irrational, real, or non-real, so please put a real there. And just remember that the table will be given to you. And for the integers, please evaluate the expression. You'll see why that's true. So I'll pick a few. The first one, square root of 16. See, it looks like a square root, so you're thinking to yourself, it's probably irrational and real. But you have to simplify first. So the square root of 16 is 4. And now that it's simplified, you'll see that this is an integer. It is rational. It is also real. Okay? Let's take a look at one like number 5, which is square root of 20. So if we simplify the square root of 20, we can break it down to the square root of 4 times the square root of 5, because 4 is a perfect square, and we get 2 square root of 5. So because that square root is still there, it is not considered to be an integer. So that just keeps it to being an irrational and still real, because remember that both rational and irrationals are real. Okay, let's take a look at one more over here, probably 3.67. Okay, so 3.67 is a decimal, but if you look in your table, decimals can be rational as long as they're not infinitely random decimals. Okay, so anything that can be written as a fraction is considered rational, and if it's rational, then it is also real. Guys, take a look at some of these. Classify each statement as true or false. All integers are real. Well, all integers are rational, and all rationals are real. So this is a true question. All real numbers are irrational. Well, if you look at the question we just answered, we know that real numbers can be rational and irrational. Thus, not all of them have to be irrational. Only some of them are. So, it's got to be false. All integers are rational. Well, if you look at that integer case, all integers are part of that rational group. That's got to be a true statement. Let's simplify a few of these. Let's pick 2 on the top, 2 on the bottom. We'll start with the first one, 5 square root of 36. Well, we can't simplify the 5. We can simplify the square root of 36. Square root of 36 is 6. Multiply your 2 numbers that are outside the radical together, and you get 30. Let's simplify 60. So we've done 12 and 15. Square root of 60. So we need to find a perfect square that's a factor of 60. We'll go down your list. We got 1, 4, 9, 16, 25, 36, 49, and we can stop right there because everything else is greater than 60. So let's go up our list. Well, 49, no. 36 times 2 is 72, so no. 25 times 2 is 50, so we're close. 16 times 4 is 64, we're getting close. 9 times 7 is 63, nope, so let's try 4. 4 times 15, there we go. So square root of 4 times square root of 15. Simplify the square root of 4 to give me 2. Some of you guys are thinking to yourself, well, can I split this up into square root of 5 and square root of 3? You can, but notice how 5 and 3 are neither perfect squares. So that means we have to keep it as the square root of 15 because it cannot be simplified any further. Let me just make it very clear that's a 15. Okay, square root of 15. I'll start 2 in the bottom here. Let's go with 17. Square root of 4 divided by 25. Well, if I take that, well, I can't simplify the fraction 4 over 25, but I can take the square root of the numerator divided by the square root of the denominator. So the square root of 4 is 2, and the square root of 25 is 5. Gosh, my 5s keep looking like 8s here. Okay, and I can't simplify that fraction anymore, so I'm done. I'll take a look at 19. It is the square root of 36 divided by 12. Well, I could take the square root of the numerator and denominator, but if you notice, 12 is not a perfect square. So maybe let's just simplify this. Simplify the fraction on the inside. Well, 36 divided by 12 is 3. So now we have the square root of 3. Can we take the square root of 3? Well, it's not a perfect square, and 4 is not a factor of 3, so I guess we're just done with the square root of 3. Simplified as much as possible. Okay, let's pick a few of these. Let's do maybe 21, 23, 26. Let's do 24 as well. Maybe let's pick a few of these exponent properties. 28, 29, and 33. So let's go down the list here. So we got addition, we got subtraction, we got multiplication, and we have some exponent properties of radicals. Well, addition and subtraction is, you can only combine like terms if they have the same radical and the same number underneath the radical. So look at 21. I have 2 square roots of 7 minus 5 square roots of 7. So only think about the coefficients because the square root of 7 is the same. That gives me negative 3 square roots of 7. Okay, number 23, well, square root of 8 and square root of 18. They're not like terms, but we can simplify them. Where in the last case, square root of 7 could not be simplified. So I'm going to take a second and simplify the square root of 8 and the square root of 18. Well, what's a perfect square that goes into 8? If you want to take a look at our perfect squares right up here, we have square root of 4 times square root of 2. Remember to keep that square root symbol until you've taken a square root. Square root of 4 is 2. Square root of 2 does not simplify, so I get 2 root 2 for square root of 8. Let's do 18. 4 is not, but 9 is, so square root of 9 times square root of 2. Well, the square root of 9 is 3. We can't simplify the square root of 2. So now we have our two simplified roots. So I'm going to rewrite the square root of 8 as 2 root 2, plus I'm going to rewrite the square root of 18 in the simplified form, 3 root 2. Well, now look, they're both root 2s, so all I'm going to do is treat it just like question number 21 and add the coefficients. So if I have 2 root 2s plus 3 root 2s, I now have 5 root 2s. Okay, take a look at 24. Square root of 8 times square root of 2. You could simplify them separately, but because they're both square roots, you might as well multiply them together. Square root of 8 times square root of 2, multiply the numbers underneath the radical, and that gives me square root of 16. And we can simplify the square root of 16 to give you 4. 26, same idea. Well, we can't simplify the square root of 5, but we can multiply these two terms together to see what we can simplify it to. So I'm going to multiply the coefficients. 3 times 2 gives me 6. And I'm going to multiply the numbers underneath the radical, which gives me the square root of 25. And now I just need to simplify the square root. Well, 6 can't be simplified, but the square root of 25 is 5. Multiply those two numbers outside the radical together, and you get 30. Okay, let's take a look at 28, our first exponent property. Okay, so when we're multiplying two terms together, we multiply the coefficients and add the exponents. 3 times 5 gives you 15, and I have x squared times x to the 4th, so I add the exponents, and I get x to the 6th. Okay, 29. Well, it looks pretty good because I can't really multiply, there's no addition, subtraction, but I have a negative exponent. So what you need to do is you need to figure out what's being raised to the negative exponent. The only thing that's being raised to the negative exponent is that x. So that's the only thing that moves to the denominator. So the 6 stays up in the numerator, and the denominator now becomes x to the 3rd with a positive 3 because I moved it from the numerator to denominator. Last one, 33. So we have 3x to the 5th, y to the 3rd raised to that 3rd power. So that means I need to raise every single part to the 3rd power. 3 to the 3rd, x to the 5th to the 3rd, and y to the 3rd to the 3rd. Okay, well 3 to the 3rd is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. X to the 5th to the 3rd, that means we multiply exponents, a power to a power. So I have 15x. Y to the 3rd gives me y to the 9th. If you don't remember why that's true, think about what the 3rd power means. It means there are 3 of them. So x to the 5th times x to the 5th times x to the 5th. Well, now we add the exponents. 5 plus 5 plus 5 gives me x to the 15th, which is exactly what we get. Okay, and now we are done. Take a look at all of our work. On the next page, we have one more question. Based off the perimeter of the rectangle is found by adding twice the length and twice the width. The area of the rectangle is found by multiplying the length and the width. You need to find the perimeter and the area of a rectangle whose length is 2 plus square root of 10 and whose width is square root of 10. Well, it tells me I need to find adding twice the length and twice the width. So that means I'm going to add 2 times 2 plus square root of 10 plus 2 times square root of 10. Well, let's simplify that right here. Distribute this 2, so I get 4 plus 2 square roots of 10 plus 2 square roots of 10. Well, 4 is not a like term with 2 square roots of 10, but 2 square root of 10 and 2 square roots of 10, I now have 4 square roots of 10. So this simplifies to 4 plus 4 square roots of 10. Now let's take a look at the area. It says the way to find the area is by multiplying the length times width. So I need to multiply the square root of 10 times 2 plus the square root of 10. Well, this is distributive property. Think about if I had 2 times x plus 2. I would distribute that 2 to both terms. Now I'm going to distribute the square root of 10 to both terms. Well, 2 times the square root of 10 is just 2 square root of 10. And square root of 10 times square root of 10, we multiply the numbers underneath the radical, so I get square root of 100. And now we can just simplify that square root. So I get 2 square root of 10, which cannot simplify, but the square root of 100 is 10, and we cannot combine like terms, so now we're all done. If you'd like some extra credit, please fill out the remainder of this review sheet and then turn it in.